All right, I went ahead and did 2.3 in 2 videos because computer output is quite a bit different. So I'm gonna go ahead and zoom in here. So right here, I've kind of went ahead and marked this up so we could look at it. So a couple things on your paper, it won't be marked up like this. So first, R squared adjusted, we never use that. Never within the context of this class, ever. Okay, these 6 numbers up in this top right corner, some of them we'll use later and some of them we won't. But for right now, we're just going to disregard those. We have 1, 2, 3, 4 numbers on this computer output that you need to know what it is and how to apply them into the problems. So the first one, R squared, is just simply R squared. There is nothing to that. That's the coefficient of determination. S is the standard deviation of the residuals, and they just give that to us. So you have to know what S is. And you have to at least have to know what R squared is. Like this question, it could say, what percentage of the variation in Y is attributed to X? But it would say that with context, of course. And you would need to know that that's R squared, and then that's where you would get that percentage from. All right, the 2 that we have to be the most careful with, that's the most used, is these 2 numbers right here. So we have the constant, and then the units for whatever X is. In this case, it's Mentos. And you can read the problem. It's about jamming Mentos in a 2-liter bottle, which hopefully you did that in middle school, and all the soda goes flying all over the place. It's actually a pretty fun experiment. But anyway, so that's what happens. So that's the X units. What's the number that's right across from that is the number that's attached to that Mentos. So see, in my equation, that's the slope. So the coefficient of the slope, or coefficient of the Mentos, that's the slope. This one says constant, and it's constant because no matter what I plug in for Mentos, this 1.00208, that is constant. That does not change. So whatever across from constant is the y-intercept, and whatever's across from the Mentos is the slope. And then that Mentos is the x variable. So it makes it much easier to write the equation. So they'll ask you to write an equation from computer output, and you need to know where to get the slope and the y-intercept from, and then we can ask you questions about these other 2. Never this, not this for several months from now. So there we go. There's computer output. Now this one also gives us the scatter plot and the residual plot, but we could actually get these from without that. All right, so what is the equation of the least squared regression line? So cups hat, the predicted number of cups is y-intercept plus the slope times the number of Mentos that we plug in. And there you go. All right, interpret the slope. So for each increase of one of whatever X is, for each single increase of 1 Mentos added to the 2-liter bottle, we predict or expect the amount of soda expelled to increase by whatever the slope is. And I guess I rounded it here, but whatever. We're not going to get into it, but either way, that's just fine. Okay, what is the correlation? So that's a question they could ask you. And you have to know that correlation is R, which we can get from R squared by taking the square root of it. Also, I know this is given to you as a percent, 60.2%, and I'm not saying you can't get the same answer, but I think you're going to be a little bit happier if you type in the square root as a proportion instead of a full number percent. So you take the square root of 0.602 and we get 0.776 on the calculator. Now, is it positive or negative? Well, this clearly shows a positive relationship, or the direction is positive, and our slope is positive. You also cannot make the argument that putting in more Mentos would make less soda come out. That doesn't even make sense. But they won't usually give you all 3 of those, but we did have that in this one, but one of those 3 will be available. Is the linear model appropriate? This is on your tests. Yes. The residual plot shows a random scattering of points above and below and we're going to get a quick facelift on this one too, the least squared regression line for all values of X in context. So Mentos. So yes, the residual plot, not the graph, not the dots. The residual plot shows or has or contains or something, you could change that around, a random scattering of dots or points above and below the least squared regression line for all values of Mentos. Okay, Would you be willing to use the linear model to predict the amount of Diet Coke expelled from 10 Mentos? And the answer is no, because this is extrapolation. It's outside the observed values of 2 to 5. So on the test, some forms will ask you to extrapolate and some won't. If I gave you a question that's not extrapolation and they ask you for the prediction, you'll do it just like this. If it is extrapolation, you'll say, no, that's extrapolation. All right, calculate and interpret the residual for a bottle of Diet Coke that has 2 Mentos and lost 1.25 cups. Okay, this is a test question as well. So cups hat, and you have to include the cups hat, and you put the equation with the number you're substituting in for X, and make sure you substitute it in the right spot. You multiply that in, and we get an answer. That's the expected amount. The original is the observed minus the expected, and we get this value right here. Okay, so our residual is 0.10626. And then we interpret that. The actual amount of Diet Coke expelled was 0.10626 cups more than the expected amount. And you have to start with the actual and then compare that to the expected. If you say the expected was less, then you're interpreting a negative number, and we need to interpret a positive number. All right, there's a bunch of good stuff there. Interpret R squared and S. So that's still using this from this table right here, not this one. This will be something else. So R squared was 60.2%. 60.2% of the variation of the Diet Coke expelled, the variation in Y is accounted for by the least squared regression line relating X to Y in context. You could have also said 60.2% of the variation in Diet Coke expelled is accounted for by the number of Mentos. That's a shorter way of saying it. I think I like that one better. It's definitely easier to remember. Okay, and then the interpret S, when using the least squared regression line to predict the amount of Diet Coke expelled by using the number of Mentos, our predictions will typically be off by 0.067 cups. And again, I rounded that. You could put the whole decimal. I guess obviously we won't be able to be too picky about that on the test. Now, these two are more commonly used as not where I ask you to interpret it. But if I give you this computer output model and I said, what percentage of the variation in Coke expelled is directly related to the number of Mentos, you need to know that that's the interpretation of R squared and come and give the answer for R squared. If I said, when using the least squared regression line to predict the amount of soda expelled by using the number of Mentos, how far will our predictions typically be off by? And you would need to know that it's here, the standard deviation. And the units is whatever Y is, or the response variable. All right, then we have another one, another problem, another set of practice for this question right here. So with this output. So we got, again, R squared adjusted, no. These 6, no. All right, and then this is our R squared. That's our standard deviation of the residuals. And then the constant is across from the y-intercept, and days is across from the slope. Whatever this is going to be some noun or adjective, probably a noun, and it's going to be whatever the x units is, and whatever's across from it, that's the slope. So y-intercept, and then the slope is negative this time. There's my least squared regression line. You will absolutely be doing that on the test. Interpret the slope, negative 0.4434. For each increase of 1 day, and this is GPA by the numbers, we're using how many days of ISS you had to predict your GPA. For every increase in 1 day spent in ISS, we predict a decrease of 0.444 to our GPA. You notice how this is negative 0.44, but in my answer and interpretation, it's a positive number, but it decreases by that amount because it's negative. Very important detail. Interpret the y-intercept. The y-intercept is 5.5, etc. A student who spends 0 days, if x is 0, if a student spends 0 days in ISS, they would be predicted to have a GPA of 5.5046. And again, you don't have to worry about that reality and say, well, is that weighted or unweighted? It doesn't matter. Even if it's unweighted, The y-intercept does not have to make sense. It's going to be the line of best fit. All right, calculate r. So we take r squared, we square root it. When we plug that in the calculator, it's going to say positive 0.859. However, the slope is negative. The slope is negative. And even if they didn't tell us the slope, you cannot make the argument that spending more days of ISS in general makes students' GPAs go up. Hopefully, I would guess that most of you have spent 0 days. I would assume you would keep it that way. I definitely remember a few faces that got busted letting kids in the door and spend a day in ISS last year, but that's the cases that probably wouldn't affect this. The standard deviation of the residual is 1.028. Interpret it. When using the least squared regression line to predict GPA using the days spent in ISS, days spent in jail, that one might be on the test. That's awesome. But that's fine. I guess somebody's going to get a little bit of hint. Well, I guess for some of you, that's one of the contexts and one of the tests. That's why that went in there. And I guess jail's kind of like ISS, except for, jail. But our predictions will be typically off by 1.028 points. And it really, there's not much else you can do for units on GPA. Maybe we can need to come up with another problem. But whatever. A decrease of our GPA by 1.028 would be fine as well. But you just want to try to get the y units into the standard deviation of the residual. Identify and interpret the coefficient of determination. 73.8. 73.8 of the variation in GPA can be attributed to the number of days spent in ISS. That's the easier one. The other one, again, that this is maybe more perfect, but this is easier and acceptable. And again, very likely this will be a multiple choice on your AP exam, not necessarily on our test. We can do whatever we want on our test because it's only one unit at a time. But you're going to, this is the part, if you can remember this, you should be able to get the multiple choice question right on the exam. The textbook or perfect answer is 73.8% of the variation in GPA can be attributed to the least squared regression line that relates GPA to ISS. I don't even think that's as good of one, but the textbook writers are obviously much smarter than I am. Okay, and then last one, calculate and interpret a residual. This is like the third one of these we've had on our notes. This will be on the test for sure. Okay, so we have the equation, GPA hat equals, and I don't need to do a play-by-play by that one, but don't forget the GPA hat, and don't forget to plug in the number for X for the number of days of ISS, and we get an answer. So if a student spends 2 days of ISS, we would predict their GPA to be 4.6166. This person's GPA was higher. They will have a positive residual. And I take the observed minus the predicted. That's my residual. And again, there's really not units, but normally you'd want to put units. But we're also going to cover units in our answer, our interpretation. So even if you didn't put the units here, it's going to be in here. Well, it better be in there if you want to get full credit for it. And it kind of double checks yourself for that. So the actual GPA for this student, and maybe I should have said a student and gave him a name so we could have put in better context, but all we have is that context, so that's all we can do. The actual GPA for this student who had 2 days of ISS was 0.6134 points more or higher than the predicted amount. All right, there's your computer output. And this is, College Board finds this to be very important. Whether you're listening to this video while we're doing this in Unit 2 or if you're going back and reviewing, make sure that you got your computer output figured out.